Hello all, you are welcome to Samok Library. In this tutorial, we are going to solve the raw number system questions that dropped in the WASSCE June 2016 and November 2016. Objective question 2, that's June. Simplify 3 over 4 minus 2 over 3, or in brackets, times one whole number 1 over 5. Objective question 35, that's also June. Express 1975 correct to two significant figures. Objective question 5, November. Convert 0.006586 to three significant figures. Theory question 1a, June. Simplify without using mathematical tables or calculators. 4 whole number 1 over 4 minus 3 whole number 1 over 2 plus 3 whole number 1 over 8, all divided by 3 whole number 2 over 5 of 1 whole number 1 over 4 divided by 2 whole number 5 over 6. Theory question 13a, June. A binary operation is defined on the set of real numbers R by M operation n equals mn minus n minus 2n, where m and n are elements of the real number system. If 5 operation x equals 22, find the value of x. Now onto the board for our solutions. Solution for our questions, that's objective question 2, which came in June. 3 over 4 minus 2 over 3 times 1 whole number 1 over 5. The first step, we are going to convert the mixed fraction to improper fraction. And with that, 5 times 1 is 5. The result plus 1 will give you 6, which will give us 6 over 5. Our next step, we are going to simplify what is inside the brackets. We find the LCD, that's the least common denominator or the divisor for 4 and 3, and that one is 12. 4 goes into 12, 3. 3 multiplied by 3 is going to give us 9. Then we bring our sign, which is negative. 3 goes into 12 is 4. 4 times 2 is 8. And bring our 6 out of 5. 9 minus 8 is obviously 1 over 12 times 6 out of 5. 6 goes into place of 1s and into 12, 2, which will finally give us an answer of 1 out of 10. To our objective question 35, that came in June, which says we should express 1975 correct to two significant figures. 1975. The first question we will ask ourselves, what are the rules of significant figures? The first rule states that all non-zero digits are significant. Example, we have 1, 2, 3, 4, 5. They are all non-zero digits. They are significant. And the next rule states that zeros between non-zero digits are significant. Which means when we have 2, 0, 0, 1, these two zeros are always significant. And the next rule says that trailing zeros in a decimal are significant. So when we have something like 0.00200, these two zeros, trailing zeros, are significant. Remember, the leading ones are insignificant. So let's come to 1975. We are going to apply the first rule, which says odd and zero digits are significant. So it means 1 is our first significant figure, 9 is the second, third, and 5 is the fourth. So our question said we should correct 1975 to two significant figures. So our concentration will be here. Then we look at the next value to the right of the 9. If it is 5 or more, we add 1 to the 9. But if it is less than 5, we take it at 0 and just maintain it to be 0, 0 and leave the 9 alone. So we get something like 1900. Since 7 is more than 5, what we do is that we take 1 and add it to 9. When you add 1 to 9, you are going to get 10. So obviously we write something like 0. Then the 1 that will remain will add it to the 1 over here, which will give us 2. At the end we get 2, 0. Then this 1 will be changed to 0, 0. Then at the end we are going to get 2000. That will be our answer if we want to convert 1975 to two significant figures, or correct it to two significant figures. Our next question, we have to convert 0.006586 to three significant figures. And as we did previously, we saw that when we have a decimal number, only the trailing zeros are significant. The leading ones are insignificant. So if you want the first significant figure, is 6. And second, third is 8. And 6 is the fourth. So we have to correct this decimal to three significant figures. So our concentration will be here. We look at the number next to 8, to the right. So that is 6. Is 6 5 or more? 6 is more than 5. So we take it as 1 and add it to the 8. So at the end, we can boldly say that 0.006586 equals 0.00659 to three significant figures. Three significant figures, yeah, that's that.